Okay, part 4. So this is the most important part for week 3 because that's the part you will be working on for your homework. That's homework 1, which is in the programming assignment worth 15%. This is a lot bigger than exercise 1 or quiz 1, and the amount of work is also much heavier, much bigger than previous exercise or quiz. So in this problem, you will be implementing your own perceptron algorithm and its variations, and use it to classify a real data set called adult income data set. And the idea is that this data set is a collection of many people in the census, United States Census. And of course, there's no name for each person, but there's some information or some kind of features or whatever fields of each person, like an age, 40 years old, the sector he or she works in, private sector, education level, doctorate, marital status, occupation, race, gender, number of hours per week that this person worked, and the country of origin. And finally, there is an output field that is the target, that is the Y label. Okay, so these first 9 fields are the input X. Okay, they're not exactly input X because you have to do some feature map or preprocessing or transformations before you can turn these 9 fields into a vector of many dimensions. And the last column is the output Y. Now this is the training data and the dev set. The test data looks like this. It's exactly the same except that the last field is missing because that's the field that you need to predict using your model, right? Trained on the training set. Now, this is what we call a semi-blind test set. Why this semi-blind? Because everything is known except the output. So the input X are completely known, just the output Y is not known. So this is not exactly blind, because if it's totally blind, then even the input is not known. In that case, I need you to upload your model, and then I run it on some completely blind data, which you never see at all. So semi-blind is kind of convenient because I provide you the input, X, and ask you to label Y, and then you just need to upload upload the whole X and Y, so that in your submission you just add, greater than 50K or less than 50K field here, so that the submitted test data would look like very similar to training data, right? So it has all the 9+1 fields, okay? So the last field is basically, did this person earn more than $50,000 a year? So per capita income, the annual per capita income, okay? So let's take a look at these files. So this is the training data. It looks like this, right? A lot of people. Well, right, and some people are earning less than 50K, some people are earning more than 50K. The total number of this set is 5,000 training examples, and then there's also a dev set or held out set, which can prevent your training algorithm from overfitting. This is 1,000 examples. Now the test set is 1,000 as well. But actually, I did not give you this test because this test set is actually labeled, right? So this is the ground truth, which I will now give you. The file I give you is the semi-blind file, which is missing the last field, the output, right? So this is the file you'll be having in the actual data set, and you need to add this last field and submit it to me, right? Submit it onto Canvas. And part of your grade is dependent on the accuracy of your prediction and the relative rank of your model, of your prediction in this whole class. Okay, so I highly recommend you to use the terminal, which is available on Linux and Mac. If you don't have a Linux or Mac, you can SSH to the school machine. You can just SSH access what's my name on? access.engr.oregonstate.edu, right? and then you can do Python, and NumPy is there already installed. You can use either Python 2 or Python 3. On this machine, Python 2 has NumPy installed. Python 3 does not have NumPy installed. So probably if you have to work on school machines, you know it's better to use Python 2. But if you have your own Python 3 setup, like what I did, okay, so I have Python 2, and I have my NumPy installed. I also have Python 3, and I believe I also have NumPy installed here. So if you have your own installation, yeah, you can use either Python 2 or Python 3. Forward looking, it's probably better to switch to Python 3 right now, because a lot of packages like NumPy and SciPy and scikit-learn started to stop or drop support for Python 2. In the long run, maybe after 5 years, more and more people will be using Python 3. But that's a minor issue. It's totally fine to use Python 2, at least for this course. Okay, so if we look at this data set, so let's look at the training set, right? You see that there are 9 input fields and 1 output field, okay? And how do you kind of convert this set to a vector format, right? That's the feature map. That's the job of feature engineering or pre-processing the data, right? Because your perceptron would only deal with vectors, right? It doesn't understand this, like what is never married. You know, what does that mean, right? So you have to convert it first. So you notice that there is the first, a numerical field. That's the first field, that being the age of the person, and there's another field somewhere here. That's the number of hours per week that this person worked, right? These two fields are already numerical, and you would think, okay, I don't need to convert them, but actually, it's better to convert them to binary features as well. Okay, so what does that mean? Well, because if you keep them as numerical features, age and hours, it would indicate that they will have a linear interpretation. That is, either the more is better or the less is better. But is it always the case that older age is better? Not necessary, right? Well, generally speaking, yes, but after maybe 60 or 65, people retire, and then people earn less. So even though, like before 60, it is true that generally speaking, the older the better, but it's not a linear, not a monotonic scale, right? In terms of number of hours, it's also not the more the better. Well, it's generally the case, the more hours the better, but some people work like 1 hour a week, like CEO, that he doesn't need to work or whatever. He just sit on the stocks or the savings account or whatever investment, and he can still earn a lot of money, right? So it's not necessarily the case that it's monotonic or linear. So you'd better just convert them to all binary features. What does that mean? Well, it means that, for example, age becomes many binary features. By binary features, I mean each feature is the value of each feature is either 0 or 1. 0 being negative, 1 being positive. So for example, age becomes many features like age equals 1, age equals 2, age equals, say, 22, blah, blah, blah. And hours becomes many features as well, from hours equals 1 to hours equals 2 to all the way to hours equals like 100. Let's say that's the maximum number of hours you can work per week, right? So each person can only have one age feature on and 1 hours feature on, right? You cannot be both age 22 and age 45, for example, right? So, for example, this first person in the training set, he's age 50, then among the age features, from age equals 1 to age equals, let's say, 100, only age equals 50 is on for that person, okay? All the other age equals whatever features are off or negative. And okay, this person works 13 hours per week. Okay, so hours equals 13 is on, or value 1. Hours equals anything else is 0 or negative feature, right? Okay, so that's how you deal with the numerical fields, age and hours. What about other fields? What is like bachelor's? What is divorced? What is private? Well, you need to convert all of these to binary features as well. Okay, so for example, you would say this is the second field, which is called the sector, the employment sector, private sector or government, or self-employed, or state government or federal government or local government, right? So you would have different features for this field as well. So if let's say there are 10 sectors, I just made it up, 10 different sectors that a person can work on, work in, and then you have 10 features for this field, right? And the next field is basically the education level. And let's say the education level runs from high school to college to master's to doctorate to whatever. So let's say there are 10 different possibilities for educational level, and then this educational level field becomes 10 features, right? So education equals doctorate is a feature, which is a binary feature, and education equals high school is another feature, right? So that's what I mean on the slides by converting every single feature to binary, including the numerical features, ages and hours, and the categorical features like country of origin equals United States, education equals doctorate, marital status equals married, civil spouse, occupation equals, let's say, sales, race equals black, sex equals female, hours equals 60, country of origin equals England. All these are binary features. So every person is converted into a very, very, very long feature vector. How many dimensions? Well, that you need to work it out. And I can tell you it's about 230 dimensions, which is a hint in the homework1.pdf. You can look at that. About 230 or maybe 231 dimensions, okay? Because each field becomes many dimensions. Let's say age becomes whatever, 100 dimensions, sector becomes 10 dimensions, education becomes 10 dimensions, marital status, well, there's married, never married, divorced, widowed, separated, whatever, let's say 6 dimensions. Occupation maybe 10 dimensions, like maybe 20 dimensions. There's tech support, there's farming, there's sales, there's professional, whatever, managerial, and race, there's white, black, Asian, Hispanic, whatever. I don't know how many, like 8 dimensions, sex 2 dimensions, hours per week, maybe 100 dimensions, country of origin, maybe I don't know how many dimensions either. Right, so if you add them up, that will be about 230 dimensions, a lot, right? So each person, even though that person only has 9 fields, really it becomes 230, about 230 dimensions before a perceptron algorithm can process it, right? Plus a y, which is either positive, was either +1 or -1, right? Now, if you run a perceptron algorithm, the vanilla perceptron algorithm without averaging, you will get about 20% or 19% error rate on the dev set. Because remember, it doesn't make sense to report your error rate on training set because you can overfit your training set very easily, right? You can just remember the whole training set. So all we care about is dev set error rate, okay? Average perceptron will be much better, about 15% error rate on dev set. That's what you need to do basically for homework 1. You need to implement your perceptron. You don't want to kind of use scikit-learn's perceptron, even though you can use scikit-learn's perceptron to verify your result. But for this homework at least, you need to implement the machine learning algorithm yourself, because you need to understand the inner details of these algorithms before you can claim that you're an expert in machine learning, right? So even though our course is called Applied Machine Learning, my objective learning outcomes for you is to be able to implement the simplest machine learning algorithm like perceptron. Okay, now some interesting facts in homework 1 data. So first thing you notice is that most people are negative. Most people earn less than 50K a year. This was because the data was pretty old, like more than 20 years old. And at that time, 1994, the average per capita income in the United States is about $27,000. Okay, nowadays, I think it's more than 50K, slightly more than 50K, but still if you look at it, today's census data, more than half of people will be earning less than 50K. Okay, because there are a lot of people earning much higher than that. So the average will be much bigger than 50K, but the median will be still less than 50K. Okay, the majority of Americans, I think, earn less than 50K a year, even today. Okay, so it's not surprising at all that the data is very skewed. Only a quarter is positive. Okay, and if you look at all these fields, the second field, that is, or the third field, that is education, is by far the single most important indicator, right? So if education is doctorate, it's almost, almost a certain, but actually not exactly 100%, but like 80% of the people who have a doctorate degree are earning more than 50K. Professional school is also very positive. Master's is also very positive, but much less than professional school. And high school dropout, like ninth, so there's education equals ninth, which means high school dropout, is extremely negative. So, looking at this data, you can get some advice for your life. That is, if you have a chance to get a master's, get a degree in, PhD or professional school, then you're almost guaranteed to earn more than 50K. Okay. And married is very good, even though less than half. But never married, that is single, is actually extremely negative. It's only 5%. Why? Why is that the case? Well, it's because most young people earn less than 50K. Okay, the people who earn more than 50K, which is only a quarter in that data set, are mostly older people. Okay, mostly people like 50 years old, 45 years old. Those people are mostly married. So single is a very negative feature. So this field kind of indicates that if you're single, get married. If you're married, don't get divorced. Because if you look at the feature for divorce, it's actually also negative, not as bad as never married. And if you look at never married versus education equals ninth, never married is even worse than education equals ninth. Okay, that is something, right? Never married is even worse than high school dropouts. That is very interesting. In terms of the employment sector, self-employed incorporated is by far the best. Okay, it's 59% positive. Because you have a company and that company is actually not a small company, it's actually incorporated. Right? So if you have a company but not incorporated, it's only 30%, right? Hours per week equals 1 is actually 100%. Why? Because that person is just, sitting on the investment, right? Country equals Iran is actually 70% positive. Iranian Americans mostly working highly paid jobs, right? And in terms of occupations, executives, managerial, like CEOs, right? And professional specialty, like doctors, maybe, are best paid occupations. They're close to 50%, still less than 50% positive. And you can find some interesting combinations, such as if a person has a doctorate, edu equals doctorate, and he or she works in a self-employed incorporated sector, then it's actually 100% positive, right? So here, I will demo more about how you look at the data on terminal, but the take-home message is you need to be basic. You need to have some basic familiarity with the terminal and how to use Linux commands to look at the data. Because if you want to be a data scientist, right, you just have to be familiar with the terminal and how to process data on the terminal, because there's just too much data and it's too slow to write programs to do them. To do the processing, you need to use those cat, sort, cut, unique, grep, awk, all these kind of little tools on Unix. Okay, so let's look at, for example, this example. That is, how do you see what kind of values are there for a certain field? For example, okay, let's say how many possible sectors are there for the second field? Okay, so how do I do it? Say cat, and And let me do a demo. So head is basically taking the first 10 lines, first 10 examples, and tail is the last 10 lines, okay? And you can head 1, first line, okay? So now if I want to cut a field, if I just want to look at the first field, so I say field 1, no, that doesn't work because by default the delimiter is a tab. In this case, it's not a tab; it's a comma. So you have to say that, right? So if you want to cut the first field with a delimiter of being comma, then you get the first field, that is the age, right? So if you want a second field, now you get the employment sector. If you want the second and third, so you say 2 to 3, right? Now, if you just want the second field and you say all possible second fields, you got this, right? And then there are a lot of duplicates, right? So you sort them and then you unique them. Okay, these are the unique employment sectors: federal government, local government, private sector, self-employed, incorporated, self-employed, not incorporated, state government, and finally without pay. There's even without pay, right? And if you want to say how many examples are there for each type, for each unique type, well, just add -c, which means count. Okay, so 150 people worked for federal government. The vast majority worked for private industry, private sectors. That's the case in the United States, right? And the other employment sectors are all very small compared to private, right? So even if you add up all the others, it's still much less than private. Okay, that's the case for the second field, that is the sector, employment sector. The third field, you can do the same, that's education. And wow, these are the educational levels present in this data set. Okay, there is 10th grade, that means high school dropout, 11th grade, 12th grade, these are all high school dropouts. If they graduate from high school, it's high school grad, right? And you can see that by far, this is the majority. This is not a majority, this is the vast, the number, the biggest type is high school grad, all right? So amount of 5,000 examples, about 32% are high school grad, right? And then there's 9th, there's first grade. Okay, these are like elementary school dropouts, middle school dropouts, whatever. And then there's associate degree, academic, associate degree, vocational school, bachelor's degree. That means people who have graduated with a degree from college. So there are actually way more people who do not graduate but attended some years, like, oh, I attended like 1 or 2 years or 3 years of college. So there's some college. And then there is doctorate, which is the smallest, which is very small category. High school grad, we just said. Master's, preschool, there's even preschool, I didn't even know that. And professional school. Okay, that's the third field. The fourth field, if you look at that, it's marital status, divorced, married, whatever, separated, widowed. Fifth field is the occupation. Okay, you can work in armed forces or craft repair or executives or farming, fishing, blah 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 blah, other services, sales, transportation, moving, blah blah blah. The sixth field is race. Amerindian, Eskimo, Native Americans, Asian Pacific Islanders, Black, Other, and White. The seventh field is gender, and this dataset is actually disproportionately more males than females. This is the number of hours, okay? Number of hours, and if you further sort it, and sort by the second field. How do you sort by second field? You say NK2. N means numerical, key 2, second field. Okay, so then it goes from 1 to all the way to 99. Okay, people can work from 1 hour to 99 hours per week, right? So, but the vast majority of people work 40 hours, just exactly 40 hours a week. That is 8 hours a day, 5 days a week. Okay, that's the majority, I think. Right. Okay. Now, if you want to sort by the first field, that is basically how frequent or how popular are these working hours. 40 is definitely the most popular working hours. 50 people actually overwork, right? 45, 60, and then less and less, right? And the least common ones are 1 hour per week, only one person, 19 hours per week, one person, right? Okay, so the vast majority of people work, these hours, right? Okay, that's the ninth. And the last input field is the country of origin. Okay, the country of origin, well, the vast majority is the United States. If you sort by the first field, okay, and sort by the first field. Oh, by the way, this vertical bars means pipe, right? So the basic idea is you run a kind of sequence or pipeline of programs. This is the first program. Its output is fed into as the input to the second program, whose output is fed into as the input to the third program, and then on. You can sequence a lot of small programs and in order to accomplish a bigger task. That's the key philosophy of Unix design. That is, each program do very small things, right? But chaining them together, pipelining them together, you can accomplish big tasks. Okay, that's very nice modular design. Okay, so where are we? Sort nk1. Okay, the vast majority is United States origin. Okay, because we have 5,000 people, only less than 500 are from other countries. Like Mexico is the biggest non-US country, Canada second biggest, Philippines, Germany, Puerto Rico, El Salvador, Cuba, Jamaica, England, China, blah 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 blah, and Italy and Iran, blah 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 blah, right? And home may be a mistake, probably Hong Kong. Yeah, okay, so this is the last field. Okay, and what about the 10th field? Well, the 10th field is just the output being positive or negative. Okay, so if you do not sort these guys, you sort and unique -c, you can see that the vast majority are negative and about a quarter is positive. Okay, now how do you look at a certain feature and say how positive is that feature? For example, doctorate, right? So you can use grep. Okay, so grep doctorate. And you don't need to even say that. You should just say doc because that's enough. Okay, there are a lot of doctorates. And how many are there? WC-L, 60 people with doctorate, right? Alternatively, you can just say grep-C, which is count 60 people there, right? Now, among them, how many people have greater than 50K annual income? -C. 48. Wow. That's how we calculate 80% positive, right? And what about doctorate? What about, let's say, never married? Never married. Well, there are 77 never married people, single people earning more than 50K. But how many people are there never married in total? Yeah, a lot, right? So that's why it's only 5%. If you're never married, there's only 5% chance you earn more than 50K, okay? Now, what about some interesting combinations? For example, what about if you're a doctor and you work for self-employed incorporated? This self should be capitalized. Okay, so there are only 3 people with that kind of combination and they're all positive, 100% positive. What if you're a doctorate and you're never married? Okay, then you can see that it's much more. So first I need to know how many. Okay, 14 people, and okay, half, right? So even though never married as a whole is only 5% positive, never married and doctorate is 50% positive. That's a lot, right? That again shows the value of education. Okay. Now you can do all kinds of interesting combinations, and I'll just leave it to you to kind of figure them out, right? Okay. Yeah. So if you want to figure out the smallest age, you can do, let's do that. Smallest age. Okay, small age is the first field. So you just cut first field. Okay, and you sort NK1. You don't need to say NK1, but just, And then you can header 1. That's the smallest age, youngest age in that data set. Biggest age in that oldest age in that data set is 90, right? Okay. That's how you kind of look at the data on the terminal. Okay. You can also look at the data on your favorite editor, but they do not do a job of doing the statistics or calculating how many people are positive, how many people are negative. Those you have to do it by grep, by WC, by cut and sort, and unique -c, right? So our TA has calculated the most positive features, not fields, but features. Remember, these are binary features in this data set. Actually, all all the positive features, meaning like if this feature means more than 50% positive, right? As we said, doctorate, professional school, and masters are very positive. Masters is positive but not very positive. But remember that if you're just a random person, you have 25% of chance getting more than 50K a year, right? Sector equals self-employed, incorporated 60%, 59%, and hours per week equals 99, 60%. Hours per week equals 6801, 100%. Because this is just like one single data point. So it could be an outlier, it could be noise, or it could be just a person who is sitting on his or her investments. So he or she does not need to work, right? And 68, probably just one person. Those doesn't make much sense. Country of origin equals Iran is the most interesting. It actually has 70% positive. And if we look at those Iranian Americans, okay, how do I do that? Our favorite friend, grep Iran. Okay, so how many people are coming from Iran? Well, -c or just or only 10 people. But among these 10 people, seven of them, yeah, are positive. And you can look at their kind of occupations: professional specialty, executive managerial, professional specialty, right? Craft repair, right? He's one of the three less than 50%, right? So the majority of Iranian Americans here in this data set work in professional specialty or managerial positions, right? And in terms of education, they are doctorate, bachelor's, doctorate, bachelor's. They're disproportionately highly educated compared to the rest of Americans. Compared to kind of an average American, Iranian Americans are much higher educated and they work in highly paid jobs, right? So that's why in this data set at least, Iranian Americans are much higher paid, right? So that's what you need to do for this homework, right? Okay, so then we'll talk about okay, so let's continue. And in order to kind of produce a very good prediction system on homework 1, you need some engineering tips or tricks or methods or whatever kind of recipes, to help you build a very accurate system. So perceptron theory in itself is good, but vanilla perceptron, as we always say, doesn't work very well at all. Okay, and it will achieve about 19% error rate, whereas if you just add averaging, it will be improved to about 15%. That's a lot. That's a big improvement. So average perceptron is the biggest improvement on perceptron. Myra is a much smaller improvement. So Myra is better than vanilla Myra is better than vanilla perceptron, and average perceptron is better than vanilla Myra, which is similar to average Myra and similar to SVM and similar to logistic regression, which will be the last part of week 3. So all these predictors perform roughly the same accuracy, with roughly the same accuracy. But average perceptron is by far the easiest one to implement, and also very fast to train. If you work on homework 2 in week 5, you realize that SVM is much slower to train than average perceptron, and they work roughly the same in terms of accuracy. And also, in homework 1, we ask you to do some interesting experiment where you would put all the positive class first and followed by all the negative classes, negative examples, and that would kind of be very, very bad for perceptron. And in that case, shuffling the data would help by a lot if the classes were ordered. But this homework 1 dataset comes kind of unordered or kind of already shuffled, right? So the positive and negative classes are interleaved at least. But if you have a dataset where it's not interleaved, which is kind of clustered positive and negative, then you need to shuffle them, right? And some people also shuffle before each epoch, and that helps a little bit, but that depends on the randomization. It depends on your luck, basically, right? Sometimes it helps, sometimes it doesn't. In general, it seems to help, but machine learning is a very empirical field. It's basically like alchemy. It's nothing like beautiful like in theory, right? Unlike majority of computer science, which is very abstract and beautiful, machine learning is by no means beautiful. Okay, machine learning is kind of one of the ugliest or dirtiest fields in computer science, right? So many things that you just cannot explain. Okay, sometimes variable learning rate or decaying learning rate also helps. So far, we have been using a constant learning rate of 1, and if you just use a constant learning rate of 10, that doesn't matter at all because the weights will just be 10 times bigger, and they have exactly the same boundary. But if the learning rate decays, like from 1 to 0.9 to 0.8 or whatever, that often helps a little bit because as training goes on, you want to be making smaller and smaller updates. So to stabilize the classifier, maybe initially you want to make kind of bold updates, but as training progresses, you want to be more and more conservative. Okay, and you can still prove convergence for some of the decaying scheme, like say maybe 1 over total number of updates or 1 over total number of examples. But that's optional. You don't need to do that for homework 1. You could if you have extra time. The final 2 tips that we discussed in exercise 1 would help a little bit in homework 1 as well. So the first one is centering each dimensions to zero mean. So for example, if your data was like distributed this way, and you center the first dimension, and it will become like this. Okay, and for sure it would help because after centering, after you get a zero mean, your radius is smaller, right? Previously your radius is here, right? This is your radius previously. Now your radius is here, much smaller, and also your margin is bigger. This is because you have the extra dimension of bias, right? So even though the margin in the original in one dimension is the same, but because you have the extra dimension of the bias, so your actual margin is actually kind of skewed. So your actual margin is actually bigger when you zero mean, when you center each dimension. Okay, that you can explain very well. Unit variance also helps that for each dimension you make it kind of a zero mean and unit variance. So each dimension looks like a unit Gaussian. So your previous margin is very small, now your margin is very big. So these 2 things generally help a little bit as well. Okay, so as an aside, we also need to talk about feature maps in other domains. So we've talked about how to convert from a person, which has 9 fields, age, occupation, educational level, hours per week, blah, 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 into a very, very long vector. How many dimensions? About 230 dimensions. Okay, so how would you do it for an image, right? You also need to convert it to a very long vector before the perceptron can process it, right? For example, this is a 28 by 28 grayscale image. That means it has only one color. It's not like RGB or real color. It's just like grayscale. Okay, so we convert it to a vector of 784 dimensions. So that's just 28 squared, right? So even though this image is kind of a 2D structure, two-dimensional structure, really we convert it to a very, very long 1D vector. Okay. Now, what about a color image, like RGB image? Well, RGB image is basically each pixel has 3 channels, red, green, and blue. So we convert it to, a real vector of 23 by 23 by 3. So it's 3 times more than a grayscale image, right? Okay, but either way, it's just a very, very, very long vector. Now, how would you do it for text? Like words, for example, English words. Okay, how many words are there in English? Well, a lot, right? Let's say 10 million. Let's just roughly estimate to 10 million. Then you create a 10 million dimensional vector. It's an extremely sparse vector where only one dimension is on. Okay, so if you sort words in an English dictionary in an alphabetical order, so is the first word. Let's say abbreviations is the second word, blah, blah, blah. And zoology is, let's say, the second last word, right? So A is represented as a vector where the first dimension is on, the other dimensions are off. Abbreviations is the second dimension on, the other dimensions off. And zoology is the second last dimension on, the other dimensions are 0. So this is called one hot, because only one dimension is hot, and everything else is kind of cold or not fired, right? One hot representation of words, okay? Because each word is different, so you have to use those many dimensions. So if you have 10,000 words, you have 10,000 dimensions. You have 1 million words, you have 1 million dimensions. Okay, and if you want to train a, let's say, spam classifier, spam filter, right? And then each word, you have a kind of vector, right? And then you can train a weight vector of that many dimensions as well. And then the weight vectors can pick up, like certain words are just very likely to be associated with a spam, for example, right? So how do you represent a text as a vector? One hot is just the simplest way to do it, and then you have bag words, which is just, if you have a phrase like a zoology professor, you just add up the vectors from zoology and from professor, then you have a vector of 3 hots. That's just the simplest and most naive way of representing text. And in later weeks, like after midterm, we'll talk about more about classifying text or dealing with text, or in other words, problems in natural language processing. And this is just a very, very brief overview that try to convince you that machine learning is all about feature maps, right? So before you do anything in any domain, your first job is to define a feature map that converts your input in whatever kind of modality, image, text, video, this kind of 9-field spreadsheet of adult income data set into vectors, right? And then you can apply whatever machine learning algorithm you want, right? Perceptron, SVM, logistic regression, blah, blah, blah. But before you do that, yeah, feature map is the first and most important thing.